Okay, so we're back on workbook page 216. Sorry, we had a little interruption. So this is section 10.2, the practice page for probability. We've already started talking about probability, and we had an activity in class, and we will finish with experimental probability the next time we have class. But this is just the general probability of something. So the description says, or the directions say, describe the likelihood of the event given its probability. So number one, again, there's a 30% chance of snow tomorrow. So the probability of snow is 30 out of 100, which is equal to 3/10, which is equal to 30%. And that means that it's probably not going to snow. And so the word that you'd use there is it's unlikely that it's going to snow. You solve a brain teaser 0.75 of the time. Well, if we change that to a percent, it's going to be 75 over 100, which equals 75% of the time. That means you solve them a lot, solving these teaser questions, brain teaser question. And so that means you do solve them more often than not, so it is likely that you will solve the next brain teaser that you have. The next part about randomly choosing one hat from these different hats is going to be pretty easy. I think you guys will be just fine with those. Well, let's do the first one, choosing a red hat. We need to, again, look and see how many different hats you have. If you want to draw it out, you have 3 green, 4 black, 2 white, 2 red, and 1 blue. And then we'll just make one that's blue. So you can call that one the blue one. Okay, so from that, you get to see how many total hats you have. So it looks like you have 3, 6, 9, 12 hats total. So the probability of choosing a red, well, the red are 2 out of 12. And then you'd put that down into lowest terms, 1 out of 6. Easy peasy. Go ahead and finish that page. Now we're going on to page 220. Workbook page 220 is asking you to use the bar graph to find the experimental probability of the event. So we're going to be looking here, and remember, we always want to read around our pictures of any kind before we start. So this is drawing a marble. So I don't think this means drawing out a marble. I think it means pulling a marble out of a bag. Times drawn. Okay, so how many different times you pull a marble, and then the color drawn. Okay, that makes sense. So you have numbers here, color drawn. I'm going to put numbers on top of here just so I can see them a little bit better so that I only have to read the bar graph one time. So blue was 4, red is 6, because I can see across here that's 6. Green is 4 also, same height. Yellow is 2, orange is 3, and purple is 1. So if I had to figure out how many total times you drew marbles, I'd add all these up together. So 4 plus 6 is 10, plus 4 is 14, 15, 16, 17, 18, 19, 20. Now I'm going to double check because I don't want to mess up. So I'm going to start adding this way now. 1 plus 3 is 4, 5, 6, 7, 8, 9, 10, plus 6 is 16, 17, 18, 19, 20. Okay, so there's 20 total times that you draw the marble. Okay, use the bar graph to find the experimental probability of the event. Drawing red. Well, red was 6 out of 20. So that goes down to be 3 out of 10. Easy. Let's jump down to number 4. Drawing a color with more than 4 letters in its name. More than 4. Blue has exactly 4, so that's not more than 4. We got to make sure we know more than 4 is not 4. Red, nope. Green, yep, that's one that has more than 4 letters. Yellow has more than 4 letters. Orange has more than 4 letters. And purple has more than 4 letters. So I'm going to add up all of these. So 4, 5, 6, 7, 8, 9, 10. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 out of 20, which equals 1/2. And that's it. Number 5, there are 25 students' names in a hat. You choose 5 names. 3 are boys' names and 2 are girls' names. How many of the 25 names would you expect to be boys' names? Okay, so boys' names was 3 out of 5. In other words, 3/5. So 3/5 of, code word of, means to multiply. 3/5 of 25. I'm just going to make that into a fraction, and then we can do factor bubbles, divide by 5, which I know you can do in your head, but for the CASP test or for any high importance test, you might as well just write it out. Give yourself the benefit of the doubt. Now you multiply straight across the top, straight across the bottom with your new numbers. 3 times 5 is 15 over 1, which equals 15. How many of the 25 names would you expect to be boys' names? 15 boys' names. This is plural possessive, so the apostrophe goes after the S. Boys is names, but we just say boys' names. Okay, that makes sense because 3 is more than 5. 3 is more than half of 5, and 15 is more than half of 25, so that makes sense to me. And then down below is the rolling a number cube. Remember, I told you they were going to call a die a number cube? There it is. That's just like the activity we did in class. Okay, next page. 224. 224. Use a tree diagram to find the total number of possible outcomes. Well, tree diagrams really just help you decide what kind of different choices there are. So there's a couple ways you could do this. In general, all you do is you create tree branches with each one of these choices branching out to each one of these choices. So this is what I mean. If you had twin, then you had twin XL, then you have full, queen, and king. Each one of these has the pattern, has the style choice of solid or patterned. So it would be S and P for each, which stands for solid and patterned. But you don't have to write it out each time. You can just abbreviate it. So each of these could be solid and patterned, solid and patterned, solid and patterned, solid and patterned. So one of your choices could be, you could get size twin in solid. That's one choice. Size twin in patterned. That's another choice. Size twin XL in solid, size twin XL in pattern, size full in solid, size full in patterned, size queen in solid, size queen in patterned, size king in solid, size king in patterned. So if we count up all the end of these branches, and sometimes they list out the names exactly just what I said out loud, but it's easy to see that there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you can surmise, if there were 5 choices of sizes and 2 different styles, what could you do to figure out the total number of choices or possible outcomes? You're thinking. Yep, you can multiply 5 times 2 and get 10 possible outcomes. Okay, so you're going to try it here, but I want to caution you. You want to make sure that you know how many different choices there are. So I'm going to do it with the photos for you, just in case you're not familiar that the numbers and how they work each mean a size of photo. So you could get a wallet size photo, that's one choice. 4 by 6 is another size. A larger picture you might get is 5 by 7. 8 by 10 is another one. 11 by 14, that's an unusual size. And 16 by 20, that's a big picture. So if we were looking at the total choices, this is 1, 2, 3, 4, 5, 6. 6 different sizes. For the finish, you either have matte or glossy. Matte means just not quite as shiny. And edits, they could do fixing red eye, in case your eyes looked red, black and white. So that could be one of the ways you could have your pictures in black and white. So red eye is one choice, black and white is the other. Or they could crop your pictures. That means where they make it smaller and they focus on just one part. That's 3 choices. Again, you're going to multiply the choices together. So 3 times 2 is 6, times 6 is 36. There's going to be 36 possible outcomes. Now you try it for number 3. Next, you spin a spinner and flip a coin. So these are 2 separate events. So you have to look at the spinner and see what is the likelihood of spinning any of these numbers. Well, this is a fair spinner. It looks like they're each equally able to be spun. It's not like one piece is bigger than another piece. So it looks like they each have 1 out of 5 chances of being spun. So we're going to put that. Chance of spinning a 2 is 1 in 5. Any of the numbers would have been 1 in 5. And flipping tails. So you're flipping a coin. Flipping a coin only has 2 choices, heads or tails. So the chance of getting tails is 1 out of 2. And guess what you do to find the probability of the event? Same thing as up above. You're going to multiply. 1 out of 5 times 1 out of 2 is going to equal 1 out of 10. So 1 out of 10 times a person might spin the number 2 and flip tails. Okay, so you try. Spinning a number 7. Do you see a 7 on here? I don't see a 7 on there, so that's kind of messing you up. So you're going to have to think through number 5 and 6. Turn the page to page 228. Okay, so this is again just like what we did with rolling the dice. We're going to be rolling a number cube, so it has how many choices, how many different sides. Yep, it's got 6 sides. And you're going to roll the number cube twice. Find the probability of the event. Rolling a 3 twice. Well, probability of rolling a 3 once is 1 out of 6. Probability of rolling 3 the next time is again 1 out of 6. You multiply them together and you get 1 out of 36. Okay, so that should be good. Next part, you choose randomly a letter from a hat, the letters A through J. Without replacing the first letter, you choose a second letter. Find the probability of the event. This is actually the most important thing to know, without replacing the first letter, because you just changed the total number of choices. So let's first figure out what A through J is. A, B, C, D, E, F, G, H, I, J. I'm going to double check, make sure I didn't miss any. A, B, C, D, E, F, G, H, I, J. Okay, now I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's 10. So I know the probability of rolling or picking out of the bag an H is 1 out of 10. Now, if the H is gone, there's not 10 choices anymore. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 choices. And one of them is a D. So 1 out of 9. And then, of course, you multiply them together. So you have a 1 in 90 chance of picking first an H and then a D. Okay, so you're going to try these out. Make sure that you have the idea. Let's go ahead and go down to number 10. You flip a coin and then you roll a number cube twice. Find the probability of the event. Okay, flipping heads, well, that's a choice of 1 out of 2 possibilities. Rolling a 5, that's a choice of 1 out of 6. And rolling a 2, 1 out of 6. You multiply them together. 2 times 6 is 12, times 6. 6 times 12 is 72. 6 dozen, yo. And now we're through. So you have a chance of 1 out of 72. The probability of doing those 3 things would be 1 out of 72. Then you just have to think through the rest of these. Figure out what the chance is of getting the number and then multiply them across. Okay, I'm going to stop there and go to the next video.